Good morning and welcome to Efficient Networks Intro to TCPIP. My name is Chuck Chumbley, and in this course we're going to cover IP version 4, and we will discuss the fact in the first chapter that TCPIP is actually an industry standard suite of protocols. We'll look at the different portions of TCPIP, we'll discuss the RFCs that comprise them, and also the different utilities that make TCPIP version 4 a fully routable, robust, scalable protocol. The overview of this chapter, we're going to discuss what is TCPIP, also the TCPIP utilities, how to install and configure Microsoft TCPIP, and also how to test with TCPIP, ipconfig, and ping. A historical view of TCPIP: in 1969, ARPANET was commissioned by the Department of Defense. This is TCPIP in its infancy, and as we see, up through about 1984 is the whole evolution of the protocol suite. Notice that Telnet, which is terminal emulation, came into play about 1972. Telnet gives us the ability to access, for instance, a mainframe computer. Also to Telnet and gain access to an efficient speed stream router, for instance. Also, FTP, the file transfer protocol, allows bidirectional transfer of information between two computers. We're not restricted to only communicating with Microsoft computers with FTP. We're looking at the fact that we can copy files from a Unix computer, Macintosh, and so on with FTP. TCP, the Transmission Control Protocol, was introduced in 1974. TCP is one of the integral parts. Notice TCP and IP are the two protocols that actually make up the protocol suite. IP came into play in 1981. TCP/IP protocol suite, the two were combined and established in 1982. And DNS, the Domain Name Service, came into play in 1984. DNS is the service that allows us, instead of typing an IP address whenever we browse a website, to type in, for instance, a URL, www.microsoft.com. Microsoft TCPIP, as we've discussed, is an industry standard suite of protocols. Later on in this chapter, we're going to cover the different components that make up the whole protocol suite. Also, TCPIP is a routable enterprise networking protocol, meaning that we're not limited to only a certain segment of a corporate LAN. We can communicate internally between different departments and also externally from the LAN, communicating on the internet, for instance, a WAN access protocol. It is also a technology for connecting to similar systems, meaning that, once again, we don't have to communicate only with Microsoft products, Microsoft operating systems. We can also communicate between a Unix host, a Macintosh host, Novell, and so on. TCPIP is also a robust, scalable, cross-platform client-server framework. Robust meaning the fact that it is routable. It is able to be installed on Windows 3.1, Win95, Windows 98, Windows NT, Windows 2000. Also, we can communicate with foreign clients such as Novell, IPX/SPX, for instance. And it is also the method for gaining access to the internet. As discussed, TCPIP is made up of many different individual components. FTP, for instance, the file transfer protocol, allows bidirectional communication between two computers or two hosts on a network. We're not limited to, once again, communicating only with two Microsoft platforms. A Microsoft Windows 95 computer, for instance, can share information. We can either upload or download information from a Unix host, for instance. Also, TFTP also provides bidirectional communication. We can upload, download files, but TFTP is normally used for smaller bits of information. We're looking at kilobytes instead of megabytes, for instance, with FTP. Also, Telnet, we've discussed, is terminal emulation, allowing us to gain access, for instance, to a mainframe computer. Also, we can Telnet into a router interface, for instance. ipconfig is one of the most powerful utilities, or the most commonly used utilities inside of the protocol suite. ipconfig allows us to verify the correct installation and also configuration of TCP/IP to an IP host. Also, ping verifies communication between not only the local network adapter on the PC, but also allows us to verify communication between two hosts in a local network or even outside of our network on the WAN, for instance. With ping, we can verify connectivity to Microsoft.com, efficient.com, for instance. Also, traceroute is a very powerful utility. With traceroute, we can verify communication, or how many router hops, how many routers that we communicate with in gaining access to a foreign website or to a foreign domain. To install and configure Microsoft TCP/IP on a Windows platform, and keep in mind that we're looking at either the NT40, either an NT4 workstation server computer, or Windows 95, 98, mainly in this presentation. To install TCP/IP on a Windows platform, and this is very similar for either a Windows 95 or a Windows 98 computer, even Windows NT, we first of all select Start, Settings, and Control Panel. Inside of the Control Panel dialog box, notice the network icon. If we double-click the network icon, we then have several possibilities. Notice that we see client for Microsoft Networks, dial-up adapter, and so on. These are the services, protocols, and also hardware that are installed on the machine. Notice that TCP/IP is already installed. If it was not, I would click the Add button, select Protocol, Add again, and in the left dialog box, label Manufacturers, we select Microsoft. And under Network Protocols, we scroll down and select TCP/IP. Select OK. A shortcut to this whole process on a Windows 95 or 98 platform, from the desktop, if I right-click Network Neighborhood and choose Properties, we have the same interface. Once again, selecting Add, choosing Protocol, and going through the same process. Once we have TCP/IP installed on the local machine, if I select TCP/IP and choose Properties, notice under the IP address tab we have two options. If I select Obtain an IP address automatically, we're choosing the DHCP service function, which is Dynamic Host Configuration Protocol. This allows the automatic allocation of an IP address, subnet mask, default gateway to the local machine. The DHCP process will be discussed more in depth in Chapter 6. At this point, we need to take a look at how to specify an IP address. If I select Specify an IP address, I must then manually type in an IP address, subnet mask, and also default gateway. By selecting Specify an IP address, we must manually enter the IP address, subnet mask, and also default gateway information. The drawback of having to manually enter all this information is, imagine having 400 computers inside of our company. An individual or a team of individuals would have to go around and physically enter this information on each computer or interface that needs an IP address inside of the organization. The chance of human error in mistyping one of the values is very great. Two hosts cannot have the same IP address. If one of the IP address or subnet mask is mistyped, that host cannot communicate on the network. DHCP is the preferred method for a network administrator anyway. Makes our job a lot easier. We're going to take a look once again at DHCP in Chapter 6. To test Microsoft TCP/IP, we're verifying that TCP/IP is actually installed and bound to the network adapter card, verifying that we have communication with not only the local network card, but also other hosts inside of the organization. Hosts being other computers, network printers, routers, anything that has an IP address for communication. The first step in verifying communication is from a DOS prompt. We type in the keyword ipconfig. Once we type in ipconfig and press enter, it then lists all of the IP address, subnet mask, default gateway. We can also verify the configuration of a Win server, DNS server, and many other options. Step number 2 is to ping the loopback address. Notice the IP address 127.001. This is an industry reserved IP address for verification that we can communicate with the locally installed network card. Step number 3 is to ping the IP address of a local host. A local host is a host or a computer near us in the same domain, for instance. Step number 4 would be to ping the IP address of the default gateway. The default gateway is the near side of the router, the local router that we use to gain access to the internet is the default gateway. Step number 5 is to ping the IP address of a remote host. Now this could be a remote host inside of our own organization, possibly outside of our domain. If our machine is seated in the engineering domain, for instance, and we need to verify communication with a remote host, this could be inside of the sales domain. This could also be a machine or a website outside of our organization. Ping www.microsoft.com, for instance. To access a command prompt from a Windows 95, 98, or an NT-based computer, if I click Start, Programs, MS-DOS prompt, we can then gain access to the DOS emulator on the machine. The first step in verifying the TCP/IP configuration on the local machine is to type in the keyword ipconfig, which once again verifies the correct installation and configuration of the TCP/IP properties. If I have 2 or more network cards installed on the local machine, each one will be listed. Notice that the Ethernet 1 properties, Ethernet 1 adapter properties include the IP address, subnet mask, and default gateway. If TCP/IP was not installed correctly on the local machine, or if we had a duplicate IP address on the network, we would see all zeros listed for the IP address, which would at that time prompt us that either IP is not installed and correctly bound to the network interface card, or that we have a duplicate IP address on the network. We have further troubleshooting tools. If I type in the keyword ipconfig once again and use a /all switch, this lists all of the possible configuration properties of TCP/IP. Notice that I first of all see a description of my network interface card, also the physical address, which is the MAC address. We verify that we are using DHCP and it is enabled. Also the IP address, subnet mask, default gateway information. We also see the IP address of the DHCP server, Win server, which is the Windows Internet Name Service. Wins provides us the means of mapping a computer name to an IP address. So if I need to access another user's computer inside of our organization, I don't have to remember the IP address. I can type in the machine name. We also have a backup Win server possibility. We also verify when the TCP/IP lease was obtained from the DHCP server. Notice the date and time, also when the lease expires. On a Windows-based machine running the Microsoft DHCP server service, the default TCP/IP lease is 72 hours. And we're going to discuss once again more in depth the DHCP functions in Chapter 6. The next step in verifying the TCP/IP configuration on the local machine is to ping the loopback address. As we discussed before, The loopback address is 127.0.0.1. This IP address is a Class A address, which we're going to discuss more in depth in Chapter 2. This is an industry standard or reserved address for testing communication with the local adapter card installed in the machine. Once I press enter, notice that I'm receiving successful replies, which means that the machine or the operating system can actually communicate with the network adapter card, which verifies that I should be able to send and receive information over the network infrastructure in the building. The next step in verifying, step number 3, in verifying the TCP/IP configuration on the local machine is to ping the IP address of a local host. A local host is one that's in the same subnet or the same location inside of our building. Notice that my IP address is 192.168.53.185. I should be able to ping anyone with the same IP scheme in the first 3 octets, with only the difference being in the 4th octet. So if I type in the word ping and the IP address of a local computer, and press enter, we then see a successful reply, which verifies communication to a local computer, one that's in our same proximity. Notice the next step, number 4, is to ping the IP address of the default gateway. The default gateway is our local router, our access point to other networks either inside of our same organization or externally from our building, possibly the internet. Remember that once again, if I type in the keyword ipconfig, I can verify the IP address of my default gateway. If we then type in the keyword ping, 192.168.53.200 is the IP address of my default gateway. If I press enter now, notice that we're receiving successful replies, which means that we can communicate with the router. So any information that I try to access, send, or receive through the local router should be successful. Step number 5, notice, in the whole process of verifying or testing TCP/IP with ipconfig and ping, is to ping the IP address of a remote host. So back from a command prompt, if I type in the keyword ping, I can either type in an IP address of a remote computer, one outside of my organization or one outside of my local network, or we can type in a URL such as www.efficient.com, pressing enter. Notice that the IP address is in a different class. My local IP address bound to my machine is a Class C address. Normally, I would not be able to communicate with the Class A IP address of 12.37.63.1 without a router in place. So we've successfully verified communication with a remote host by passing through at least 2 routers, my local default gateway, and also the router which connects to Efficient's website at the Class A IP address that we see listed. A shortcut to verifying the successful installation and configuration of TCP/IP on a Windows-based computer, instead of going through the 5 steps as we've seen listed, is to, first of all, in step number 1 from a DOS prompt, type in the command ipconfig and verify that TCP/IP is installed on the local machine. Instead of following steps 2, 3, and 4, if I then skip to step number 5 to ping the IP address of a remote computer or a remote host, if step number 5 is successful, steps 2, 3, and 4 are not needed. In review of Chapter 1, we first of all discussed what is TCP/IP. TCP/IP is actually 2 protocol suites that have been combined. First of all, we see the Transmission Control Protocol and also Internet Protocol that have been put together to define an industry standard suite of routable, robust, scalable protocols. The TCP/IP utilities, we've discussed the fact that there are many components inside of the protocol suite. We've discussed ping, ipconfig, also traceroute, many utilities to verify the successful installation and configuration of TCP/IP. Also, we've seen utilities which allow us to copy files between two computers. We've discussed FTP, the file transfer protocol, which provides once again bidirectional communication between two computers. Also TFTP, the trivial file transfer protocol, which also allows bidirectional communication, but it's normally used for smaller amounts of information. Also, we've taken a look at how to install and configure Microsoft TCP/IP on a Windows-based computer, accessing control panel, double-clicking network, and then adding and configuring the protocol, either manually, the static assignment of the IP configuration, including the IP address, subnet mask, and default gateway. Also, we briefly discussed DHCP, the Dynamic Host Configuration Protocol, which allows the automatic configuration of the TCP/IP address, subnet mask, default gateway, and so on. We've taken a look at troubleshooting TCP/IP with ipconfig and ping,